Hi, I'm Dennis Phillips, and welcome to Everyday Reloading and Shooting. All right, welcome back to the channel. Once again, we're at the Georgia Gun Club's 100-yard indoor rifle range, and today I'm shooting my Tikka T3X mounted in an MDT Oryx chassis with an Arken SH4 60-24x50 rifle scope. And today we're testing ammo, which is loaded with the VHT N133 powder and the 60-grain Vmax bullet. We are shooting charge weights today from 22.3 to 23.5 grains of powder. At the higher end of the velocity range, these should be traveling 31 to 3,200 feet per second. So as always, you're welcome to enjoy the music while I fast forward through my shooting, or you can skip forward to the results that follow. Shooting at 100 yards. All right, most of these didn't perform that well, but I had a couple of groups that looked okay. So let's bring them in and take a look. All right, so we started out here at 22.3 grains at 2,824 feet per second. These were both shot, this was shot with a 52 grain boat tail hollow point. The rest of these were shot with the 60 grain Vmax. Pretty scattered here, tightening up, scattered, a little tighter. One of the shots that belonged over here, I accidentally shot over here. That was this one on the bottom here. So we will back that out when we measure them. So anyway, we will take these home, measure these with a Hornady ballistics app, and get back to you with the results. So stay tuned. All right, we're back from the range, and I've had a chance to measure and analyze my targets. We're experimenting with the Hornady 60 grain Vmax bullet and the VHT N133 powder. This particular powder is a relatively fast burning powder. It's number 69 out of 170 powders on the Hornady burn rate chart. Now, in the Hornady manual and on the Hodgdon Reloading Data website, there's no load data for this particular bullet and powder. So I had to go to the VHT website, and they don't show load data for a 60 grain Vmax bullet, but they do have load data for a 60 grain Sierra hollow point bullet, which is very similar, the only difference being a hollow point versus a ballistic tip, but they're both 60 grains and they both have flat bases. So I would expect them to perform similarly. Now, in that, the maximum charge weight for that particular powder and bullet combination is 23.5 grains. So in developing my load data, what I did is I started off, I don't shoot that charge weight first, but what I do is I start from there and I work my way backwards in 0.3 of a grain step increments. So I go from 23.5 to 23.2, 22.9, 22.6 to 22.3. And what we found was one of our best performing groups was at that 22.3 charge weight. And the starting charge weight is less than that. So it's very possible that since these groups tended to open up somewhat as we increase the charge weight, we may need to go back and look at some of those lower charge weights that we haven't explored yet. We may have to take a look at that because there's a very good chance that we could find a better charge weight in there. Now, on these, we always shoot a fouling group with 5 shots. And on this, instead of wasting the Vmax, which I'm testing, I had some 52 grain Hornady boat tail hollow point. And so I used those for the fouling group. And that also happened to be one of my best groups, if not maybe the best group. So here's a picture of that group. And as you can see, here's my coal barrel shot at the top. That was my very first shot. And then the next 4 after that all clustered together in one tiny group here. We had a group size of 0.74 inches with a mean radius of 0.23. But if you back that flyer out, then that group size goes to 0.36 inches. Very tight. So the 52 boat tail hollow point might be something that we'll need to experiment with because that really performed well on that first group as a fouling group. So just to look at the target as a whole, again, we've got charge weights from 22.3 to 23.5. We saw no pressure signs with any of these, so we were all good on all of these loads. All right, so with our first group at 22.3 grains with the 60 grain Vmax bullet, we have basically a horizontal string in our impacts. We're at 1.3 inches. But they're impacting horizontally there because we have a really good standard deviation at 6.8 feet per second. Now, you do also notice that as we go from the 52 grain bullet to the 60 grain bullet, the velocity decreases at first. And then, of course, it increases as we increase the charge weight. But at the same charge weight, that velocity drops from 28.59 to 27.90. Because you're shooting a heavier bullet. We go to 22.6 grains of powder. We now have a group size of 0.79 inches and a mean radius of 0.30. We've got an average velocity of 28.20 and a pretty decent standard deviation at 9.3 feet per second. That might be an area where we could develop with either neck tension or seating depth. At 22.9 grains, the group is opening up. We've got a flyer out here, so now we've got a group size of 1.91 inches with a mean radius of 0.54. We're traveling at 2,874 feet per second, and we have a standard deviation of 6.8. Kind of hard to understand how you can have a good standard deviation but have such a scattered group. And I guess it's just this bullet and powder combination. At 23.2 grains of powder, we tighten up quite a bit. We have a group size of 0.54 inches with a mean radius of 0.20, which a radius being half a circle. You double that, and now you've got a group size of 0.4 inches. We're traveling at 2,920 feet per second, and we have a standard deviation of 13.2. Now, I mentioned here, there's a little arrow with a note here that says belongs here. I shot a 6 bullet at this target. I was supposed to be shooting the 23.5 grain target, and I messed up and I shot one of those shots at the 23.2 grain target. And I remember where that was because I remembered what that group looked like before I hit it with this other round. So on our last target at 23.5 grains of powder, we only have 4 shots. But we've got a group size of 1.17 with a mean radius of 0.37. We're traveling at 2,967 feet per second, and we have a standard deviation of 24.9 feet per second. So if we're going to develop a load here, we're probably going to be looking at this 23.2 grains of powder because we did have a really good result there. And we might come back to this 22.3 grains because we had a good standard deviation there. And with the 52 grain boat tail hollow point, we also had a really good group there. So again, because these groups tended to open up as we increase the charge weight, and we've got room to decrease that charge, we may find a load here on the lower side of that 22.3 grain charge weight where we'll get a good result. But if you're going to give this a try, the 23.2 grains might be a good place to start with this powder and bullet. All right, so those are my results. I hope you find this information helpful. If you have any ideas, thoughts, suggestions, questions, please leave those in the comments section below. I try to interact with everybody that comments. I hope you will also like, share, and subscribe. And as always, thanks for watching.